These are the sum and difference identities. I would certainly write these down somewhere, have them somewhere, know where to get to them. Definitely helpful. What these allow us to do is actually find some more exact values for sine, cosine, tangent, and the like. So we're going to use these. We want to find the exact value of each of these trig expressions. Here we want to find sine of 15 degrees. Well, how can we get 15 degrees out of the different values we already have? Well, we can rewrite this as sine of 45 minus 30. We know sine of 45, we know sine of 30, and that can get us 15, because we know 45 minus 30 is 15. So now we're going to perform our difference identity. Sine of alpha minus beta, some value minus some value, sine of A times cosine of B minus cosine of A times sine of B. So this is essentially sine of 45 cosine of 30 minus cosine of 45 sine of 30. Notice how 45 is my A value, 30 is my B value, my alpha, my beta. Just plugging those into my identity. All right, so there we go. Now we know these values. We know sine of 45. We know cosine of 30. So we evaluate. All right, we know sine of 45. It's root 2 over 2. Cosine of just 30 degrees, that is square root of 3 over 2. Cosine of 45 is root 2 over 2. Sine of 30, that is a half. Going up a half. All right, so now we can simplify this. This is root 6 over 4. This is root 2 over 4. We can simplify this a little bit more. This is root 6 minus root 2 over 4. We got it as just one single fraction. Nothing else we can do. We can't reduce those roots. We can't do anything like that. And you can always go back and double check. Type this sine of 15 degrees in your calculator and make sure it matches up to this, especially as we're getting going with this. Definitely check yourself. Make sure it makes sense. Here, tangent of 7 pi over 12. Well, we don't have anything over 12 on our unit circle. But think about what's going to have a common denominator of 12, and that's if we have something out of 3 plus something out of 4. We know that the common denominator of 3 and 4 is 12, and this would be 1 pi over 3 plus 1 pi over 4. Go ahead and double check that to yourself. That would be 4 over 12 plus 3 over 12, which gives us 7 over 12. So now we want to rewrite this with our tangent angle sum formula. So we look back here, tangent alpha plus beta, tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. All right, so this is going to be tangent of our alpha plus tangent of our beta over 1 minus tangent of pi over 3 times tangent of pi over 4. Yeah. All right, so that's what we're dealing with right there. We now just have to simplify it. We know tangent of pi over 3, tangent of pi over 3, that point pi over 3. Of course, we're going over a half, up root 3 over 2. We know tangent sine over cosine, so that's just going to give us root 3. Tangent of pi over 4 is the easy one. It's 1. On the bottom, we have 1 minus root 3 times 1. So now we just clean this up. This becomes square root of 3 plus 1 over 1 minus the square root of 3. We can't leave that radical in the denominator, so I'm going to multiply the top and the bottom by the conjugate of the denominator be multiplying it by 1 minus, sorry, the conjugate of 1 minus root 3 would be 1 plus root 3. We do that to the top and the bottom. On the top, we get root 9 plus 2 root 3 plus 1. In the denominator, we have 1 minus root 9. We clean some things up. This becomes 3 plus 2 root 3 plus 1 over negative 2. Continue cleaning it up. We get 4 plus 2 root 3 over negative 2. Divide everything by negative 2, and we get negative 2 minus root 3 as our most simplified value. You can always double check this. Type that in your calculator, make sure that the decimals are the same. That's what our answer should come out to be.